This week we're talking about series parallel AC networks, and I just wanted to give you a quick introduction here. Let's look at a circuit. Let's see. Go to the next. Okay. So here we have a 20-volt source. We've got an inductor here in one branch and a resistor and capacitor in the other branch. So what this looks like is if we looked at block impedances, we've got Z3 over here, that's our inductor. Z1 is our resistor over here, and Z2, which is our capacitor. So what we see is that we've really got a parallel circuit with a series element over here. So let's first just kind of look at our block impedances. So Z1 is 5 ohms, 5 at 0 degrees, or 5 plus 0J, whichever way you want to note that. Z2 is actually going to be 0 minus 12J, or 0 minus J12, same thing, or 12 at negative 90 degrees. And for Z3 over here, our inductor, that's going to be 0 plus J8 or 8J, or 8 at 90 degrees. Again, if you want to use polar form, that's fine. If you want to use rectangular form, that's fine. So if we sum Z1 and Z2, we get 5 minus 12J. That would be the impedance of this entire branch. Remember, impedances that are in series, we would add them to find the total impedance of that branch. And if we convert that to polar form, that's 13 at an angle of negative 67.38. Okay, so let's talk about how we might find V sub C and I sub S for our circuit here. There are a few different methods of doing this. I'm going to show you just a couple. So for VC, one way is we could recognize that Z1 and Z2 make up a voltage divider because series impedances divide the voltage just like series resistors in DC. So VC would be the portion of E that would mirror the ratio of Z2 to the overall impedance of the branch. So we're going to apply the voltage divider rule here, where we're going to multiply by our source voltage and multiply the impedance where we're looking for the voltage. So if we want VC here, we're going to take Z2 and put that on the top. So Z2 was negative 12J, or 12 at negative 90, same thing. And then on the bottom will be the total resistance of our divider circuit, which is Z1 plus Z2, 5 minus 12J. Okay, so this gives us 18.46 volts at an angle of negative 2.62 degrees. Another way we could have solved this is to find I2 first. So I2 is the current through Z1 and Z2. So in order to do that, we recognize that our source voltage is the voltage drop across both Z1 and Z2 at the same time. So we would take our source voltage, 20 at 20 degrees, and divide by the impedance of the branch, which is 5 minus 12J. That would give us about 1.5 amps at an angle of 87 degrees. And then we could just multiply by, since that's the current through both Z1 and Z2, we can just multiply Z2 by that current to find VC. So once we do that, we get the same thing that we found up here, 18.46 volts at an angle of negative 2.62. Now, if you need to pause the video at any time and kind of think through that and back it up, please do that. That's one of the benefits of using video in this case. Okay, so let's look at finding I1. That's the current through Z3 over here. So Z3 is in parallel with our source. So if we divide our source voltage by Z3, we would get the current through that inductor, which is about 2.5 amps at negative 70 degrees. The source current is just going to be the sum of I1 and I2. So if we add I1 to I2 that we found here, we would get 1.232 amps at an angle of negative 41.3 degrees. What you might have thought from the beginning was just to find ZT, and then divide your source voltage by ZT to find I sub S, and that works just as well. So I'll show you those calculations as well. So you could do 1 over Z3 plus 1 over Z1 plus Z2 and find your ZT that way. You could also do product over the sums. Product over the sums means we would take this impedance and multiply by this impedance, and then we would divide by the sum of Z3 plus Z1 plus Z2. And that's what we've done here. So that will also get us ZT. So you could do it either way. So you could do it the other way and then check to see that you get the same answer here. And then, of course, for I sub s, we just take our source voltage and divide by that ZT. And of course, we get exactly the same thing that we did over here. So I want you to practice this week working through some of these problems. I've put about 5 other problems in the folder for you to work through. If you want to see more examples,